Today, we are going to learn what is deep learning. Modern AI can recognize your face, transcribe your voice with high accuracy, and even generate realistic video from a few words of text. We see these results every day. But beneath the interface, a complex process is happening that most users never see. Peeling back the layers of how these systems work reveals an approach to computing that differs from everything that came before. For decades, traditional machine learning relied on humans to provide the logic. We wrote the rules, and the computer followed them, which worked well for organized, simple data. But those rules fail when a computer is faced with a blurry image, a muffled voice recording, or a complex pattern it hasn't seen before. The real world is not a clean spreadsheet. It is unpredictable, and logic-based rules are often too rigid to handle that level of variety. To navigate this chaos, researchers moved away from rigid programming and toward deep learning. This system takes its cues from the human brain. It is built to analyze information layer by layer, building understanding through connected nodes. By adopting this biological model, computers can finally begin to interpret the messy reality of the physical world. These systems are called neural networks. Think of them as stacked layers of digital neurons, where each specific layer is responsible for one part of the analysis. At the start, the first layer scans raw pixels to find simple edges in the static. That data moves to the next layer, grouping lines to form geometric shapes. Deeper in the network, these combine to identify distinct features, like the contour of a face. Understanding is a sequence. The machine builds a complex concept out of thousands of simple observations. We can see this logic clearly if we look at how a system identifies a photo of a cat. When the image is uploaded, the machine is initially blind to the subject. To the computer, this isn't an animal. It's just a grid of millions of numerical color values. But as the data flows through the pipeline, those numbers are sorted into edges, then into complex patterns, and finally recognizable cat-like features. By the time the data reaches the final layer, the system has bridged the gap between pixels and language, assigning the label cat. Despite the biological inspiration, this isn't a mysterious process. It is a predictable, mathematical system. The architecture is a linear flow. Raw data enters as input, is processed by the neural network layers, and results in a prediction at the end. Deep learning is a structured pipeline designed for high-level pattern recognition. This architecture is already embedded in the tools we use every hour of the day. It powers the facial recognition on your phone, the navigation in self-driving cars, and the algorithms that suggest what you should watch next. These hidden neural layers are now the primary way we interact with information. In the past, computers only knew what we told them through handwritten rules. If a scenario wasn't in the code, the machine couldn't handle it. Today, machines are finding the rules themselves by identifying patterns directly from the world around them. We have moved from a time where we programmed computers to a time where we teach them. But it's important to be clear about what this change means. Deep learning hasn't made machines conscious or self-aware. Instead, it provided a way for machines to translate billions of points of raw, chaotic data into a predictive map of our reality. Artificial intelligence does not think. It merely recognizes patterns far better than a human ever could.